Hello everyone. The title of this video is Solve Linear Equations in One Variable. Every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org. I'm in their Algebra and Trigonometry text, section 2.2, titled Linear Equations in One Variable. And I'm working under the objective heading Solving Linear Equations in One Variable. So all the examples I'm doing are taken either from the examples from the reading or from some of the try it problems in the reading or some of the exercises at the end of the section that are related to this particular objective. I will also have timestamps for when I start each example in the description of the video below if you want to use those to bounce around. Also, I request that whenever I start a new question, pause the video and try to work it out yourself first before you watch me do it and then compare. Because if you're just watching me do these things and not practicing yourself, chances are you're not going to learn all that much. Alright, so all the examples I have written out on paper. So, like I said, it's solve linear equations in one variable. Right? There's just one unknown in each equation. And we're just simply asked to solve the equation. Right? Now, solving an equation simply means find all the values that you can replace the variable with to make a true statement, right? To have the expression on the left side of the equal sign actually be the same, be equal to the expression on the right side. Alright, so there really aren't any set steps. It all depends on how the equation looks. So the first, I'll write some steps over here, but just know that you don't have to do things in exactly this order. Alright, so the first thing I would do is simplify both sides completely by using the distributive property and combining like terms, stuff like that. Simplify both sides to start, alright, which means use the distributive property if necessary to get rid of parentheses. If there are any parentheses, combine like terms. If there are any, right? And this is something I'm actually going to be doing each step. All right, I'm going to be actually doing this every single step. Whenever I add something to both sides or subtract something from both sides, multiply or divide by the same number on both sides. I'll be doing this each step. After each step. So in this example here, the left side of the equal sign, 2x plus 1, there are no parentheses, right? There are no like terms, right? This is an x term, this is a constant term, they don't go together. So that side is already as simplified as it's going to get right now. And then the other side of the equal sign is just a number, right? Just -9, so that's already simplified as well. Alright, then I'm gonna use what's called the addition property of equality. Use the addition property of equality. which is just the following, right? That's if, you know, A equals B, then A plus C equals B plus C. Basically, it's just whatever you add or subtract, right? Because subtraction is just adding a negative number. It's if you have an equation and you add or subtract some number to one side, you have to do it to the other as well. And I'm going to use this addition property of equality to get all the terms with the variable, right, with the unknown letter on one side of the equal sign, and terms without the variable on the other side, right, constant terms, and terms without the variable on the other side. Okay. So here, now terms, remember terms are products, right, that are separated by addition. So the left side, has two terms. There's 2 times x, that's a product, then plus, and then a separate term, right? Terms are separated by addition. And then 1, right? So 2x and 1. Then the right side has just a single term, right? -9. There's nothing being added to that. All right, so the only term, that has a variable is 2 times x. So what I want to do is I want to do adding or subtracting to get rid of the +1 term. Now since it's +1, I want to add -1, right? Subtract 1 to make that 0, to make it disappear, right? So then we have 2x plus 1, on the left side, and I'll leave a little space, equals, and then, -9 on the right. And then here comes that, addition property of equality. I'm adding -1, or just subtracting 1 from both sides. Right? So that's using the addition property of equality here. And then, like I said, I'm going to go back and I'm going to be simplifying both sides after I perform each step. So now the left side, you can add the 1 and -1 to make 0, and I have just 2x. And then simplifying the right side, -9 and -1 can go together to make -10. And now both sides are simplified. All right. Then finally, well, not finally, I guess the last step should always be to check your solution. But then I'm going to use the multiplication property of equality. Right. Now, multiplication and division go hand in hand. Right? Division is just multiplication by the reciprocal. Use the multiplication, I guess I could put /division. I put addition /subtraction. I should have put that earlier. Use the multiplication / division properties of equality, property of equality. Sorry, that's supposed to say equality. That's really tight over there. But that's the following here. That's if A equals B and C is non-zero. Right, so up here C could be anything when you were adding or subtracting. Here, when you're multiplying or dividing both sides by a number, you can't multiply both sides or divide both sides by 0. Right? That actually won't help you in any way. So if A is equal to B and C is not 0, then A times C will be equal to B times C. Also, A divided by C will be equal to B divided by C. Right? But again, C, you can't divide by 0. That's why I'm pointing out that C is a non-zero number. Also, if you multiply both sides by 0, you'd get 0 equals 0. That would be true, but it would get rid of anything. It would get rid of all the information. If you multiplied both sides by 0, you'd end up with 0 equals 0, which doesn't help you solve for the variable, right? The variable is eliminated in that case. So use the multiplication / division property of equality to isolate the variable. I want the variable by itself. So any numbers attached to the variable, I don't want anymore. So here I have 2 times x. I don't want the 2. Right? This is multiplication by 2. So to get rid of the 2 and keep x alone, we can divide both sides by 2 or multiply both sides by a half. Right? Dividing by 2 is the same as multiplying by a half. Right, so again, I'm going to use one of those properties of equality. Right, we have 2x on one side, negative 10 on the other, and then here comes division by 2, right, dividing both sides by positive 2. Right, and then simplifying, right? This is done after each step. Simplify both sides. 2x divided by 2, the 2's cancel. You have x on the left equals, and then negative 10 divided by positive 2 is negative 5. Wonderful. And then finally, and this is something you should do no matter what, anytime you deal with equations, check your solution. Right? Check solutions, and you always check back in the original equation. Right, let's check it. So I'm going to replace x with negative 5 back in the original equation, simplify both sides, and see it, we get a true statement. So it'd be 2 times, again, x is replaced with the number negative 5, and then you got plus 1 equals negative 9. 2 times negative 5 is negative 10. Right, so now the left side is negative 10 plus 1 equals negative 9, and negative 10 plus 1 is negative 9. You get negative 9 equals negative 9. This is a true statement. And so now I will box my answer. This is a solution to this equation. It's a good solution. Right, it is a value that can replace the variable with to make a true statement. X equals negative 5. Now another way that you might see this written is that the solution set of the equation, the solution, you're going to see this for equations and inequalities. The solution set of this equation is the set, right, little braces for a set, with just the number negative 5 in it. Right, that's the only number that belongs to this set. Right, and this is saying the same thing as I did earlier, right? That x can be replaced with negative 5, and the statement will be true. So you might see them writing this kind of stuff out in certain exercises in this text. Right, wonderful. So yeah, so I'm going to be again I'm going to do the simplify both sides step all the time, right? After every time I perform the addition or subtraction property of equality, every time I perform the multiplication or division property of equality, I'm going to then simplify both sides and keep going until I get the variable alone on one side equal to some number on the other side, and then of course check it back in the always check it back in the original equation, please. Okay, wonderful. All right, so let's continuing doing these same steps. Alright, so number 2 is a little more complicated, but still going to be performing the same procedure, same steps all the time. Right? So the first step was, if you can simplify things right now on both sides, do that. So I'm saying this area here with the parentheses, there's a sum or difference in parentheses. I can use the distributive property to get rid of those parentheses, and then we can combine like terms, simplify this left side. So don't forget to distribute the negative, right? Negatives are part of terms, negative signs. Negative 2 times 3x, that's negative 6x. And then negative 2 times negative 1 is positive 2 for the next term. And then you have this plus x that was after that, equals 14 minus x. And then the left side, you got some terms that you can put together, these x terms, negative 6x plus 1x is negative 5x. And then you still have this positive 2 term, right? So there's the left side, totally simplified. And then the right side is still, 14 minus x. You can't combine these, right? Great. All right, so now I'm going to use that addition property of equality or subtraction, right, to get all the terms with the variable on one side and terms without the variable on the other. All right, now I personally like having the variables on the left side all the time. It doesn't matter. All right, you choose. So here's our left side, negative 5x plus 2. I'm going to leave some space for what I'm going to be adding and subtracting. And then the right side, 14 minus x. Alright, and then I'm going to perform that addition property of equality, right? So if I want the variable terms on the left side, means I don't want the positive 2, right? So I'm going to subtract 2 from both sides, okay? And then if I want all the variable terms on the left side, means I don't want the variable terms on the right side. Right? So there's a minus x here. So to get rid of that, I need to add x. Right? So I'm also going to add x to both sides. Right? And then we simplify. Right? After every step I perform, we're going to simplify, combine like terms and whatnot. So on the left side, we have negative 5x plus x. That's negative 4x equals, the 2 minus 2 is 0. So it's just negative 4x on the left side. And on the right side, you have negative 1x plus 1x. Those are gone. Then you just have the constants 14 and negative 2. 14 minus 2 is 12. Alright. And then once again, I got negative 4x on the left, 12 on the right. And I'm going to perform the multiplication or, division property of equality and divide both sides by this negative 4. Right, to get rid of it, and you isolate the variable, get x alone. Or, dividing by negative 4 is the same thing as multiplying by negative 1/4. Right? You can also multiply both sides by negative 1/4 if you wish. Alright, so I'm dividing both sides by a non-zero number. And let's pull this over here. Sorry about the space. On the left side we have x equals, and on the right side 12 divided by negative 4 is negative 3. Right. So my supposed solution here is negative 3. Well, let us check this. Right, so I'm going to do this on some separate paper. Right, let's check this answer. You should always be checking your solutions just to make sure you did things correctly. Replace everywhere I see an x, replace it with the negative 3. So we have negative 2 times the quantity, 3 times negative 3 minus 1 plus negative 3, right? And I like to put you should get in the habit of putting parentheses around things when you replace them. Right? Just going to make things that much easier for you in the long run, I promise. Alright, and then the other side equals 14 minus negative 3. And let's see if this is actually a true statement. Alright, so your order of operations. You go in parentheses first, right? 3 times negative 3 is negative 9, minus 1 is negative 10. So we have negative 2 times, and then this number here in the parentheses simplifies to negative 10. And then plus negative 3 is the same thing as minus 3, right? Adding a negative. Equals, and then 14 minus negative 3, that'd be plus 3. 14 plus 3, that's 17 on the right side. and then negative 2 times negative 10 is positive 20, and then you still have this minus 3 equals 17, and then 20 minus 3 have 17 equals 17. This is a true statement. So I'm going to put this in a box now. Right? This works. This is, the solution of this equation. I can replace x with negative 3, and this will be a true statement. And that seems to be the only value you can use. Right? And once again, you might also see them writing this, right? Or you could write that the solution set for this equation is just the set with the number negative 3 in it. Right? That's the only number that we can replace the variable with and get a true statement. Right? And saying both of these is pretty much equivalent. Right? Okay, so I'm doing the same thing for all these examples. Right? So example 3. Now 7x plus 2 equals 3x minus 9. Both sides are already as simplified as they're going to be right now, so let me move on to the next steps. Next was I wanted to add and subtract, to get the terms of the variable on one side. So we have 7x plus 2 on the left side. I'm going to leave some space for what I'm going to be adding or subtracting, equals 3x minus 9. And then I'll use that, addition property, subtraction property of equality. Now let's just say again that I want all the variables on the left side. Again, you can choose the right side if you want. So that means I don't want the positive 2, right? So on the left, so we subtract 2 from both sides. And if I want all the variables on the left side of the equal sign, that means I don't want the 3x over here. So I'm going to subtract 3x from the right side, and also must do it to the left, right, to keep it balanced. Got to do it to both. Alright, then simplifying, right, always simplifying after each step. The 2 minus 2 is 0 over here, and then 7x and minus 3x make positive 4x. And then over here, the 3x and the negative 3x make 0, and negative 9 minus 2 is negative 11. And then we're dividing by 4, right? And then now I use the or multiply by 1/4. All right, but we have 4x on the left, we have negative 11 on the right. And again, I'll write the multiplication one this time. Let's times by positive 1/4 on both sides. All right, same thing as dividing by 4. And 1/4 times 4 is 1, so I'll have 1x on the left, or the variable alone. And remember how to multiply fractions. This is like negative 11 over 1. You multiply the numerators, multiply the denominators. This is just negative 11 divided by 4, right? Negative 11/4. Or if you want a decimal, that'd be negative 2.75, right? That's 2 3/4. But alright, so now off to the side, let's check this. You should always be checking. I am back in the original equation. So we have 7 times negative 11/4 plus 2. Is that equal to 3 times negative 11/4 minus 9? Alright, so 7 times negative 11/4, that'd be negative 77/4 plus, and then don't forget when you're adding numbers or subtracting, you need a common denominator. The denominators need to be the same. This is 2 over 1 up here, which would be multiplying the numerator and denominator by 4 to get a denominator of 4. That'd be 8 divided by 4, right? That's also 2. And now they have a common denominator. And when you add, right, you keep that common denominator, 4, and then just combine the numerators. Hopefully this all rings a bell, right? Negative 77, plus 8 would be negative 69. Right? So the left side simplifies to negative 69/4. And let's see if that's actually equal to what we get on the right side. 3 times negative 11/4 is negative 33/4. minus, and then 9. Remember, 9 is 9 over 1. Multiplying by 4 over 4 to get a common denominator, we get 36 fourths, right? 36 divided by 4 is 9. Got a common denominator, we're adding or subtracting, so I keep that denominator and just combine the numerators. Negative 33 minus 36 is indeed negative 69. These are the same number. This is true. And we have a solution, right? This is a good solution. X equals negative 11 fourths works. Or, once again, you could write that the solution set of this equation is the set with just negative 11 fourths in it. Right, and this is equally valid. Right. Great. And any other number you replace x with would make it false. You can try that. Replace x with any other number you want, and it'll be a false. The only one that's going to work out here is negative 11 fourths. Okay, great. All right, so next question. All right, so same deal. Right, got some parentheses involved in the beginning here. I'm going to use the distributive property to simplify the sides. All right, so I'll distribute this 3 to the quantity x plus 2. And on the right side here, I'll distribute the 5 to the x plus 1. All right, so we have 3x plus 6, and then you got minus 12 still over here, equals, and then 5x plus 5. Simplifying first, we got, the 6 and negative 12 make negative 6. So this is 3x minus 6 on the left equals 5x plus 5 on the right. So we got 3x minus 6 on the left. I'm going to leave some space for what I'm going to add or subtract. Then 5x plus 5 on the right. And again, I'll just do the same, just stay consistent here and make sure I get all the variable terms to the left side. So if that's the case, I don't want this negative 6 on the left side. So I'm going to add 6, right? Negative 6 plus 6 would be 0, and that would disappear. And then I would add 6 to the right side again as well, right? And then if I want the x's on the left, I don't want the x's on the right, so I want to subtract 5x from the right side to get rid of the 5x term. But if I do it to the right side, right, I have to do it to the left side as well. Okay. All right, and then simplifying, right? Simplifying after each step, we have 3x minus 5x. That's negative 2x alone, by itself on the left, negative 2x. And then over here, 5 plus 6 is 11. Right. And then dividing both sides by negative 2 or multiplying both sides by negative 1/2, right? Same thing. I'll write divided by negative 2. We get our final solution here, or possible solution, right? We still should check it. So x on the left and negative 11 halves, right? And a positive divided by a negative is negative. So negative 11 halves, or negative 5.5, negative 5.5 on the right. Okay, and let's check this. All right, let's check this. You should always be checking your solutions. Right, back in the original equation. So I'm going to check it 3 times, and then negative 11 halves. Now I'm not putting parentheses around it because it's not being multiplied by anything or raised to any powers, right? Or subtracted or anything like that. So I got negative 11 halves plus 2 in parentheses there. Then minus 12 equals, and then 5 times, and then in parentheses, x is replaced with negative 11 halves plus 1. And don't forget, when you add or subtract numbers, they need to have the same denominator. So this in parentheses here, this is negative 11 halves plus 4 halves, right? 2 is the same as 4 halves. Putting those together, that'd be 3 times negative 7 halves, right? And when you add numbers with the same denominator, that denominator stays, you just add the numerators. Alright, then we got minus 12 still, and let's see, multiply first, right? 3 times negative 7 halves, that's negative 21 halves, right? You only multiply the numerators and multiply the denominators when you multiply fractions. Minus, and then 12 is 24 halves, right? 24 divided by 2 is 12. And then putting these together, we get a denominator of 2 and a numerator of negative 45. Right, so this is negative 45 halves. Right, or negative 22.5 on the left side. Now let's see if that's equal to what I get on the right side. And it should be. I'm hoping it is. Now again, negative 11 halves plus 1, that's negative 11 halves plus 2 halves, which is negative 9 halves. And then 5 times, negative 9 halves is negative 45 halves. Right, 5 times negative 9, and then 1 times 2 in the denominator. And this is true. We get negative 45 halves equals negative 45 halves. So negative 11 halves here is a valid solution. Wonderful. It works. And once again, you could also say the following, right? Say that the solution set for this equation is just the set with negative 11 halves in it. Right, and that would mean the same thing. Wonderful. Okay, so this next equation has fractions, in it. Now I'm going to show you how to do this in 2 different ways. All right, one of them is just leave things the way they are and work out the same steps I've been working out in the first 4 examples. So the left side is simplified already, the right side is simplified already, so now I'm just going to perform the addition or subtraction, property of equality. Right, so we have 1/2 minus 1/3 x on the left, 4/3 on the right. If I want to keep the x term on the left, that means I need to get rid of this half. Right? So I'm going to subtract 1/2 from both sides. Right? And then the right side doesn't have any x terms, right? So I don't need to do any more subtraction. So on the left side, we have negative 1/3 times x equals. And then the right side, maybe I'll take this over here. 4/3 minus 1/2. Need a common denominator. Now I'm hoping you see that the least common multiple of 2 and 3 is 6. So I've multiplied the first fraction by 2 over 2 to get a denominator of 6. That'd be 8/6. And that's the same thing as 4/3. Minus, and then 1/2 is the same thing as 3/6. Right? I would multiply the numerator and denominator by 3. Now I have a common denominator and we can add them. Right? 8 minus 3 is 5/6. Right? Remember the denominator, when they are the same and you're adding and subtracting, that denominator stays. You're just adding the numerators or subtracting the numerators. Great. All right, so now I have negative 1/3 x on the left, 5/6 on the right, and now I'm going to get the x by itself, right? Now you could write divided by negative 1/3. Alright, but dividing by negative 1/3 is the same as multiplying by negative 3. So I'm going to multiply both sides by negative 3. Right? And any number of times its reciprocal is 1, right? So the left side is just x. And then I've already mentioned, right, when you multiply fractions, right, this is like negative 3 over 1. This would be, multiply the numerators, negative 15 divided by multiply the denominators is 6. And then you can cancel any common factors, right? These have a common factor of 3. If I divide both of these by 3, that'd be negative 5/2. Or negative 2.5. Right, when you totally reduce the fraction. Okay, so there's my possible solution. X equals negative 5/2, negative 2.5. Let's check it. Alright, and this will be the last one I actually check for. I know I've done a lot of checking here, but I'll leave the checking to you for the last page. Right? So we have 1/2 minus 1/3 times x, right? And x is negative 5 halves here. And is this equal to 4/3? Right. Let's see. So multiplying these, you have a negative 1/3 times negative 5 halves. That'd be positive, right? So 1/2 plus, 5/6. Right? When you multiply numerators, multiply the denominators. And this is 3/6 plus 5/6, right? When you get 3/6 is the same as a half, you need a common denominator. So this left side's 8/6, which does indeed reduce to 4/3, right? 8 and 6 have a common factor of 2. Dividing both by 2 here, you get 4/3, and then the right side is already 4/3, so this is true. We get 4/3 equals 4/3, a true statement. So here's the solution. And once again, you can write out that the solution set is just the set with the number negative 5 halves or negative 2.5 in it. Wonderful. Now, when there are fractions involved in an equation, there's an alternate way you can do it. Right? You can leave the fractions there and work the way I've been working. Right? I got the solution, it worked. Negative 5 halves works. But an alternate method here, you can clear fractions from an equation if you wish. You can clear fractions by multiplying both sides by the least common denominator, or some common multiple of the denominators. So this is optional. You do not have to do this, right? You see from the first way I did it, I didn't do anything. I just used the same steps as before and got a solution. But if you don't like working with fractions, you can clear fractions by multiplying by, the least common denominator, which is just the least common multiple of the denominators. Sometimes it's referred to as just, the LCD. Now look at the denominators here. They are 2 and 3. All right, the least common multiple of 2 and 3 is 6, right? 2 times 3. And that's the smallest multiple that 2 and 3 have in common. Right? So what I'm going to do is I'm going to take both sides here, 1/2 minus 1/3 x equals, and then the other side's 4/3, and use that multiplication property of equality first, right, before the addition one. Take this entire side here, multiply it by 6, right, multiply it by this LCD, right, and do the same. Don't forget to do the same thing to the other side, right, multiply by 6. Now, on the left side, there are 2 terms, so I'm going to be distributing the 6, right? You have to multiply every term by 6. Now 6 times 1/2 is 6 halves, which is 3. And 6 times 1/3 is 6/3, which is 2. So you have 3 minus 2x equals, and then over here, this is 24 divided by 3, which is 8. Right? Or you could say 3 goes into 6 twice, and then 2 times 4 is 8, either way. But do you see what happened here? When you multiply both sides by the least common denominator, all the fractions go away, right? Because all the denominators go into the least common denominator evenly, right? So now we have this equation, 3 minus 2x equals 8. And then I would subtract 3 from both sides, right, to get all the terms with the variable on one side, terms without the variable on the other, leaving me with negative 2x on the left and 5 on the right. And then I would divide both sides by negative 2, or multiply both sides by negative 1/2, same thing. And we get x alone on the left equals, and then a positive divided by a negative is negative, and then 5 halves, right? Negative 5 halves on the right. And look, this is exactly the same number I got when I did it the other way, where I kept the fractions. And people would probably argue that this is a lot prettier, this second way. So this is what I'm going to do for the last two examples. Right? The last two examples will also involve fractions. I'm going to find the least common multiple of all the denominators, or the least common denominator, or the LCD, and multiply both sides by the LCD first, and then go about solving the equation. Right? But like I said, you don't have to do that. You can keep the fractions the way they are and still solve the equation just fine, right? As long as you just know how to add, subtract, and multiply and divide fractions. Right? All right, so this last page, a couple more equations with some fractions, a single variable. So here we have 2/3 x plus 1/2 equals 6. Now the LCD is clearly 6 again, right? 3, 2, and 6 are the denominators. The least common multiple of all those is 6. So I'm going to take this equation and multiply both sides by 6. So the entire left side times 6. The entire right side, right, which is just one term, times 6. Now don't forget, this left side has two terms, so each of those, right, gets multiplied by 6. You are distributing the 6. Now 6 times 2/3 is 12/3, which is 4, or you could say 3 goes into 6 twice, and then 2 times 2 is 4. This is 4x then for the first term. Plus, and then 6 times 1/2 is 3, right? That's 6 divided by 2, which is 3. So you see how the fractions are gone now on the left side? It's beautiful, right? Equals, and then over here, the 6's cancel. You have 31. Now the fractions are gone. I have cleared the fractions by multiplying both sides by this LCD. Alright, and then I would next subtract 3 from both sides. And then we have 4x on the left equals, and then 31 minus 3 is 28 on the right. Then divide both sides by 4, or multiply both sides by 1/4, same thing. And we're finally left with, bring this up here, x on the left equals, and then 28 divided by 4 is 7 on the right. And please don't, this time I'm going to leave it to you, but check your answers, right? So that'd be I'll just do it out loud real quick, actually. That's 14/3, right? 2/3 times 7, which would be 28/6 plus 3/6 is 31/6, right? Getting a common denominator on the left there. That works. So this is your solution, or the solution set, is the set with just the number 7 in it. Alright, and then one final question here. Again, a bunch of fractions. Now you can leave these fractions the way they are and still solve the equation, no problem. I'm going to do what I did in the previous example. I'm going to multiply both sides, every single term, by the LCD, right, the least common denominator. Alright, so the denominators are 3, 4, and 6, right? Their smallest common multiple would be 12. Right, 3 goes into 12 evenly, 4 goes into 12 evenly, 6 goes into 12 evenly, and that's the smallest number that all three of those go into evenly. Alright, so I'm going to write it out again, the left side and right side. And we are going to multiply both sides by 12, the LCD. Okay. Now both sides have multiple terms. So, again, we're multiplying every term, distributing the 12 on this left side. And then we'd have to also distribute 12 on the right side. And this should clear the fractions. 12 times 2/3 is 8, so this is 8x minus 12 times 3/4 is 9. So I have 8x minus 9 on the left equals, and then 12 times 1/6, right? This is like 1x over 6, 1/6x. 12 times 1/6 is 2. So it's 2x there. Plus, and then 12 times 21/4 is 63. Right, because 4 goes into 12 3 times. 3 times 21 is 63. Okay, and then, yeah, move some terms around. So I would be adding 9 to both sides, and also subtracting 2x. To get all the x terms on the left and terms without x on the right. And combining like terms and simplifying here, we get 6x on the left equals 72 on the right, 63 plus 9, and then dividing by 6 or multiplying by 1/6 on both sides, and same thing. We get x on the left equals 12 on the right, right? And then don't forget to check your answer, please. And finally, I'll leave this last one to you, but this should work out. Right? Replace x with 12 here and here, and make sure that both sides represent the same number, that you have a true statement. Okay, fantastic. Right. Yeah, so all the same steps every time. Now you don't have to do them in the exact same order I did them. If you see a faster way to solve an equation, please do it. Just so long as you're adhering to the proper rules, right? The proper properties of equality. Right? Just remember that whatever you do to one side of an equation, you must do to the other side as well. Great. And so I'm hoping that watching me go through these 7 examples here help you in some way when you're asked to solve, linear equations in one variable on your own. And thank you very much for watching.